let's say scheduled. Yeah, it's also not live on YouTube, but I guess it's gonna be. Okay. Okay, great. Yes, we are live. Thank you thank you, Peter, the
Great.
shadow presence here. He did heroic gesture of connecting from the phone, and somehow through, I guess, the phone small interface, he managed to click go live. So we are live
Yeah,
now. Even if
great.
I don't see it on YouTube right now, there's always some delay, right? So, well,
Yeah.
welcome to this episode of Oot. I hope I pronounce it correctly in Italian with a strange accent. And I welcome everybody. And we try to keep the schedule also constant, but with the holidays and the unknowns that happen. It's called life, right?
Yeah.
So you never know
Yep.
what can happen. So yeah, this was scheduled for a few days ago, but then something happened, so it's all right. So we are here, and I'm very glad
Yep.
to be here. I don't usually host Oot, but it's always a pleasure to have a conversation with great people from the industry, great people from the community, people that really believe in the project of Istio and understand what needs to be done to push forward and get things done. And I'm really glad that I'm here with Lukonde. Lukonde, I mean, I know him from his great videos on YouTube. He even came to Amsterdam for sure. But did we spoke actually in Amsterdam? Unfortunately, I think I was so busy. I was running around organizing Kubernetes
Yeah.
Community Days Amsterdam that I'm so
Yeah.
sorry. But and also we miss each other at KubeCon Amsterdam. So I
Right.
promise next time we are in the same city, I'll bring you out for a drink.
Yeah, we have to make it
Um,
happen.
yes, like, I know, and especially with two events in Amsterdam and everybody coming, there's so many people I want to meet still, and
Yeah,
well, we still have a lot of time in front of us, right? So,
I'm
well,
sure.
so I don't think there's a lot of housekeeping to be done, but there is this goes live on YouTube, so there's always a chance to watch it later. And there is a chat on YouTube, and if I have it in front of me, so if anybody connected and watching it now wants to interact with us, I encourage to use the YouTube chat. Uh,
Neat.
so look on
Yeah.
please introduce yourself. It's your time to shine and you're the star of the show.
Yeah, sure. Well, thanks so much for having me. I love and respect a lot of what Solo is doing as a team and even the different individuals that make it up. Great contributors to the Istio project. And I've learned from a lot of you. So calling me a great member of the community is definitely more credit than I deserve, just a product of the different contributors. And I certainly just want to be a part of that, play a role in that process as well for other people who are on the learning journey and want to make use of this in their environments. My name is Lukonde Mwila. You can also call me Luke. A lot of people call me Luke. And I'm a developer advocate in the EKS team at AWS. I started off my journey in the software space as an application developer, and then eventually transitioned into performing more of a DevOps role and a cloud engineer and different forms of solution architecture. And it was in that particular time when I started working more with Kubernetes and eventually with Istio as well.
Awesome. So you are a dev converted to DevOps.
Yeah.
It's the opposite journey of many people, me myself. Like I come from the operation, right? So it's great
Yeah.
to have somebody from that background. What's your
Yeah.
what language did you program in? Just out of curiosity.
Yeah, no, sure. So the primary ones when I just started out was PHP and JavaScript. Did a lot of Node.js, a little bit of Java, not too much of it, so not super proficient at that. But a lot of the application development was in JavaScript. Sometimes also worked a bit with mobile app development as well. So been across the board in a couple of different areas, which was neat. having to work on a variety of projects. I never really wanted to be locked down to one particular language. I enjoyed having to work with different tools and frameworks.
Cool. So you're not one of those hipsters programming in Rust, or so. And I know, no offense. I mean, I actually want to learn and get more into this. Yeah, of course. I mean, it's first because FOMO, right? So the cool kids are doing Rust. So I think,
right.
you got this feeling. But indeed, it is. We can see that there's more Rust in the kernel. This brings even in the Istio community, the Z tunnel is now written in Rust. So even just out of curiosity and to understand what really goes on in the data path, learning a bit of Rust, it's good, right? So
yep.
Amazing. So you're a DevRel, right? So, and
yes,
I'm particularly interested because I'm also fresh DevRel. It's been a while now working as solo, since last December. But I come from the software engineering side of things, and I jump into the DevRel role, and I love it. In fact, it's amazing that it's for us. I think for everybody. I think it's really chaotic. So how do you deal with that? What's your role? How do you feel like being a DevRel?
Yeah, I like you. I love it. I enjoy it. I think like many people who are in this role, there's a lot of figuring out to do, and you have to make choices along the way in terms of what aspects you want to focus on. But my origins in DevRel actually started even when I was doing application development and then transitioned more into solution architecture, doing ops, etc. I was still trying to be as active as possible in the developer community and essentially playing a role of advocating for developers in different forms. A big part of DevRel is content creation. And so I was already doing that. And that just stemmed from the fact that from the problems that I faced. So if there was something that I was dealing with in a particular challenge in the workplace, I thought, well, okay, how can I make the journey easier for someone else that may be facing this? I often tell people there are two approaches. One, you can try and preempt it for people. So you come up with a problem or a use case and then build out a solution to that. Or it could be born out of something that you faced or a particular demand that you see in a particular developer community. So that's also what paved the way for me actually becoming an AWS hero, which is a great community. And that was an avenue to engage with the AWS community and developers within that space and operators in that space, as well as having a bridge to AWS. So that's kind of where it started. And then having the opportunity to do that full time, where you can influence the journey for other developers and operators, as well as influence particular products at an organization, I think is one of the sweetest spots to be in.
It's I feel like many of us just evolve into this role, right? So you happen to do things related to DevOps, something that is more like a natural thing that you do because you have passion for community, for talking to people, for helping developers, and then at some point you just accept a role, right? So it feels very natural to be a DevRel for me, at least. I hope for it definitely is an interesting role, and it's something that we see more. Actually, in a couple of days, I'm going to London to talk at DevRel Con, which is a great conference.
Great.
Next time, I think you will be great there. There's a series of conferences about Marino was there in Prague.
Yes.
And in a couple of days, there's DevRel Con London, and I'll be talking about something completely different than Istio. Which, by the way, I mean, this has been the hoot. We do. Don't worry, everybody. I mean, we'll talk about Istio in a very short moment. I have from YouTube that is not actually streaming. Okay. I think we're okay. I mean, we'll be. It's too bad because it says live, but it doesn't really get to YouTube. In any case, this is recorded and we're gonna upload the video later, so nobody worries.
Sure.
We got this. I mean,
great.
it cannot be more complicated than Kubernetes, right? So it's just a streaming.
Right.
But okay, so great. What brought you to Istio? I mean, it's something that you got from work, or somebody told you to look at the project, or something that you just like?
Yeah, that's a great question. So my first interaction or engagement with the project was at work. I was working for a financial service institution, and so as you'd expect, security is a very high priority. And so I had the opportunity to essentially be involved in architecting, the landscape for a particular Kubernetes environment and the microservices in there. And there were lots of integrations with different services around it. And even before we implemented the cluster, it was a prerequisite to have mutual authentication, because that's something that existed in other environments in that particular institution. And so we were essentially told that this prerequisite has to be met. And so we explored different projects, and we had someone on the team who was very well versed with solutions like what we were trying to set up, and that's what he proposed, and we adopted it, and then it just became this journey of learning how to figure out Istio. And I'm not going to lie, in the teething stages, I was running in the opposite direction. I was like, I want nothing to do with this. I will deal with other aspects of this project. But I also do like a challenge. And so eventually just circled back to wanting to get more involved in it. And I thought to myself that one of the reasons I was running away from it to begin with was I don't think there was enough time spent on understanding the problem definition that Istio is actually solving. And so I thought, okay, let me spend more time on understanding the problem, and that will help me appreciate it as a solution even more. And when I did that, that certainly helped. And it's one of my favorite projects. Most of my videos on YouTube are Istio based videos, as you would know. So yeah, that was basically how it started.
That's good. So, but it reflects an engineering mindset, right? So when something is hard and difficult, that's exactly where you should spend some time in understanding, right? So that's what we are here, right? So we solve complex problems. We do it, of course, for customers, right? So in the end, is the bottom line is to Peter can't hear me, but do you hear me?
Yeah, I can hear you. I can hear you just fine.
Okay. All right. Okay. So yeah, we do it for the customer, of course. Eventually, I mean, we all here to foster the bottom line and then sell. That's make no mistakes. But nobody says that you cannot do it with having a little fun or a little technical challenge, right? So to stimulate a bit your mind, and that's what we do here, right? So that's what we do at Solo.
Yeah.
I joined Solo because it was a hard problem, right? So it's still hard, right? So this application networking is it's hard to figure out and hard to attack. And I think Istio in general, for sure Istio, but also solo.io and our product really factually help customers in their journey towards the perfect, secure, perfectly observable, perfectly secure infrastructure, right? So that's one reason we are here, right? So okay, that's a lot of talk, and yes, indeed. Like I saw your videos, and that's the idea of inviting you over, because I mean we would like to get more people like you, right? So the screen went blank all of a sudden. So we want to involve more of the community. In fact, like this community needs you, right? So needs you. I'm talking to you, Luke, but also everybody that is here listening. This community, it's a big community now with the project in graduation, really graduated, and with more adoption than ever. I mean, it feels like Istio is this kind of project that everybody use but people don't talk about it. Like more crossing the chasm or crossing the curve of adoption. Now it's just becoming something that you use, but not very exciting. But in fact, it's actually a very exciting project. There is a lot of innovation coming in, and so definitely something that we would like more people to get involved at all level. Like
Absolutely.
you say, you don't need to be a coder, right? So the Istio,
Right.
in general, like the Cloud Native Computing Foundation communities, they need just people also to debate and discuss the ideas and validate ideas and concepts and proposals, and write more documentation, make more videos. So that's why I think this is a episode where maybe we go a little less technical, but definitely we would like to inspire more people to join and to be with us, right? So
yeah, absolutely.
Okay, cool. So what are you working on today? Like, what's your great that you mentioned authentication, right? So it's one of the things that really tickled my imagination when I first look at service mesh at Istio. Like I did this magic box that can always call an external authentication system and then let you in or not. It's an amazing. It's a very important piece of application networking, modern application networking. So tell me more about it. What do you do exactly? What do you integrate Istio with?
Yeah. So it will depend on a particular use case. And in my particular role with DevRel, I see different types of use cases. One of the prominent ones right now, actually just sidestepping from authentication, is the fact that a lot of people are trying to find ways of mitigating or optimizing their costs. And Istio is one of the go-to solutions for that. So a lot of the things I've been working on around Istio have primarily been related to that. But I still think one of, if not the most dominant aspect or the biggest drawing factor with Istio is its power to enable mutual authentication in microservices and environments that are running multiple services or integrating with other services. And there are different ways of approaching that. So I try to make time to craft different solutions related to different use cases and different approaches that you can take. For example, you could use Istio out the box. And by out the box, I mean rather with the default settings where Istio-D is the certificate authority for the environment for mutual authentication, or you can configure your Istio service mesh to have an upstream or root certificate authority that is external to the mesh's environment. And of course, one of my favorite approaches is also using Spire, to essentially have that separate component to provide the security identity management, essentially, for your Istio service mesh, which makes it extensible beyond just the mesh and to other environments that can make use of spiffy identities.
Yeah, that's actually, let me recap a bit, because you mentioned reduce cost. So today we are actually thinking definitely in terms of cost, like FinOps, right? So this is what we think about. But reducing cost has indirect effect of reducing environmental impact of software. And I'm involved in CNCF has a few projects, of course. There's the Technical Advisory Group, Environmental Sustainability. I try to attend most of their calls, and they produce white papers. These are real thing. With the, I'm reading recently. Burning Man was completely overwhelmed by rain and mud. So it's amazing that it's raining in the desert, right? So this is a real problem, and it's going to be even more in the future. So everyone, including us, software engineers, people building open source software, we need to do our part. So reducing cost, reducing footprint through the smart use of software like Istio, it is a real gain. And I hope to, if you want to reach out, if you want to know more, definitely there are a bunch of CNCF Slack channels that might be interest of you. And yes, and also you said, of course, accepting defaults is never a good idea. It is true that I think it's because projects like Istio want to give a great first user experience, right? So you want to install this thing quickly and just get to the learning phase, right? So that when you first approach a new project, Istio install gets you there, right? But definitely,
Yes, right.
the default are nowhere near something resembling production. But this is true for
Right.
lots of projects, right? So even
Yeah,
Kubernetes
right.
itself, I mean, it's even you get Kubernetes like completely useless unless you secure it. You install, of course, service mesh. So it's interesting. So what's the
Yeah.
advantage of having a certificate authority, external certificate authority for service mesh?
Yeah, great question. I think one of the primary ones, if not the primary reason, is in a number of enterprise organizations, they will typically have their own internal policies and approaches to how they want to issue certificates. And they'll typically decide on a particular root certificate authority. And the reason for that is they want it to be able to easily integrate to the different environments. Because in many cases, I mean, at this point in time, if I'm correct, I think the hybrid cloud model is still the most prominent one. A lot of teams and organizations are running their workloads both in the cloud and in on-premise environments. And this can extend to multiple data centers on-prem, maybe in some cases as well, different cloud environments. But the point is, how do you build or establish trust between the different workloads in these different environments? And so you essentially wanted to funnel right back to the top of one root certificate authority. And so you can have intermediary certificate authorities that exist in these respective environments, but having a root one that would essentially be the primary point from which everything else flows out of, so that you can establish that trust beyond the different environments because of all these integrations. Software today is very convoluted. Applications are not that simple. They're usually, especially in an enterprise context, there's so many interconnections. So how do you establish trust in those different environments? And so having an external certificate authority allows you to have that kind of trust in the different domains.
Yeah, that's totally true. We see this, right? So we at Solo, also AWS, right? So we are seen as expert advisors or people that know what they're doing. So it's also our responsibility to provide the best practices, and definitely centralized authority is great. So let's get to, if you want to, feel free to share your screen, show some code. I mean, we love code here at UT. So, so do you have an example of how to integrate a certificate authority? Which one, by the way? I mean, I guess it's you've been working at AWS. You have free access to all sort of resources and infrastructure. So I guess you choose one of those, right?
Yeah, I'm going to demonstrate a solution that involves AWS's Certificate Manager, both for public certificates as well as a private certificate authority for private certificates. And before jumping into the solution or example,
Well, one thing, what's the difference between private authority and public authority? Is who can access them, or?
Yeah, exactly. So your public SSL or TLS certificates are essentially associated with a public interface. So your client browser interaction with a particular website. So establishing security between the browser and the server, rather, client server model where you're accessing a particular website. So that's that external point of view is where you would make use of a public certificate, whereas a private certificate would be typically associated with your back-end environments.
Okay, so it's a matter of trust, right? So are the private is the private authority trusted only between a few services and not just publicly? That's what you mean to say?
Yes, pretty much. And look, you can configure the extent of the trust for that particular private certificate authority, and by extending the trust, I simply mean in a back-end environment.
Okay. So please carry on. I mean, I'm not too familiar with AWS. That's why the questions, right? So as you
of course.
I come from the other side of the street, right? So the other big cloud provider. So I have to brush up my AWS skills. So.
No problem. Right, and before jumping into the solution or the demo itself, I just think it's always good to take a step back and understand why you would even bother with this kind of approach. Why would you bother with securing the gateway? Why would you bother with securing microservices in your mesh? And the main thing to understand from a top level is it goes back to what you actually pointed out as well, about insecurities around Kubernetes. And so in a Kubernetes environment in the cloud, there's so many different attack vectors, and so you want to find ways of mitigating the risks associated with those different attack vectors. Could be securing your container images, could be securing the containers themselves, the software supply chain, implementing policy enforcement, securing the nodes, different ways of securing the cluster. And so what I'm going to focus on is how to secure network communication, because sure, environments vary, they differ depending on the use case, but the journey that a packet or network traffic takes will vary, and in some cases it will pass through different mediums, untrusted mediums, and some trusted mediums, but nonetheless there is the risk of how do we prevent potential interception of network traffic? And in the case that it is intercepted, how do we mitigate the risk of the message being understood by a party that shouldn't be receiving that message? And how do we ensure that any component that touches this message has a verifiable identity? So these are the different concerns that you want to make sure you're addressing, because your network traffic is going to be traversing different mediums and touching different components, and you want to make sure that your traffic is secured, the message itself is encrypted, and any entities involved in the communication, sender and receiver, have a verifiable identity in this particular process.
Yeah, definitely. And the CA is the key to the kingdom, right? So that's
right.
You only as secure as your weakest point, and that's why it's good to trust cloud providers to provide tools and mechanisms to rotate CAs and to manage CAs. So tell me more. I want to know more. Now I'm sold to the idea.
Right. Exactly. Yeah. So got a screen that I want to share. There we go. So let me make sure this is visible. Great. Now, at first glance, you see all sorts of images on this diagram and different elements, but let's follow the different path. And we'll actually start off with the component that you've been speaking about, right? The certificate manager. So I'm using AWS Certificate Manager to provide a public certificate that is going to be associated with a particular domain name and will be attached to my application load balancer. And the reason I'm using an application load balancer in this case is this application load balancer is actually managed by an ingress. And so it all goes back to why you even use ingresses in the first place. Kubernetes services are an important piece of exposing your applications to the outside world, or specifically to the scope of the cluster, but they have limitations. And those limitations are addressed by ingresses so that you can essentially have HTTP and HTTPS traffic. It's a great way of allowing entry into your cluster's environment or different environments. You may be running a Kubernetes cluster that has a particular workload that is running, or workloads that are running in a service mesh. And you may also have other workloads running in the same cluster that are not running in a mesh. So instead of exposing multiple load balancers, you could essentially have one load balancer that is managed by an ingress that allows traffic into your cluster's environment. So that's why this application load balancer is here. This is the entry point into my service mesh environment. Now, the Istio has an ingress gateway, which is the entry point into the mesh itself. And the ingress gateway can expose a load balancer, but in this setup, because I've got the application load balancer, I'm going to configure my ingress gateway so that it's just it's of a type node port. So this application load balancer proxies traffic into the ingress, through the ingress gateway, and into the service mesh itself. Now, like I was saying, there are different components involved in this process in terms of how traffic is flowing. We have a user or an individual over here that is going to access a particular website. They go to the domain name or a specific endpoint for an API. That traffic is then going to communicate with the application load balancer, which then routes the traffic to the ingress gateway. So these are different components, and there's a medium here where the traffic is traveling. So how do you secure that traffic? And so as a starting point to secure traffic between the client and the application load balancer, this public SSL certificate is associated with a particular domain name and attached to the application load balancer so that the traffic between these 2 points is encrypted and secured. But then there's the path between the load balancer and the ingress gateway. How do you secure that traffic? Which then brings us to the, another part of the AWS certificate manager, but now a private certificate authority in this case. And so I'm issuing a private certificate and storing that in a Kubernetes secret, a TLS secret to be specific, and attaching that to the gateway into my particular mesh. And so that way, this certificate attached to the particular gateway that I'm going to be exposing is then going to encrypt the traffic between the load balancer and the gateway itself. So that's the first flow, the traffic going from a public space into the private domain. But even then, you still want to secure the traffic between the different microservices as well. So I'm going to come to the next diagram here, and please feel free to interject and just stop me if you have any questions.
Yeah, so this is really a end-to-end encryption flow,
exactly.
Right? So there is a bunch of re-encryption, like changing certificates, because you have multiple gateways, so they all want to terminate the TLS connection, then re-encrypt on the other side. But it's still a full end-to-end encryption flow from the user to the microservice.
Right. Exactly. And out the box, or based on default settings, Istio does provide security and mutual authentication when you first implement your mesh in a particular Kubernetes cluster. If I'm correct, the default setting is in a permissive mode. So that means that it's not a strict requirement for both entities to have a verifiable identity in order for there to be established trust and communication between those two. But I want to start off by going through the default flow when you just install Istio. As I mentioned earlier, Istio-D plays the role of the root certificate authority. And so you've got over here, this block is essentially representing our pod, where we've got our microservice running, and then we've also got a sidecar, and the sidecar has the Envoy proxy, and there's also a component of the sidecar that is known as the Istio agent. And the Istio agent is responsible for bootstrapping the identity for the Envoy proxy. And so the Istio agent is going to communicate. So if you see here CSR, that stands for a certificate signing request. It's going to communicate with Istio-D to have the certificate signed, and then Istio-D is going to issue that certificate, which is an SVID document, SVID, which stands for Spiffy Verifiable Identity Document. So that's the spec that Istio uses. And so this is the flow that you get out the box. But we've already kind of discussed the reasons around why you might want to have an external root certificate authority, and not might. It's actually a best practice. So, but how do you actually set that up? And so this diagram has that flow. But yeah.
Just one thing. This process repeats every hour, if I'm correct. I mean, this because the certificates do expire, and
yes,
I'm not so sure about the default, but I think this happens quite often. So it's part of the zero trust security. Also, these long-lived certificates should be banned, right? So you should get this process is automated, so it can happen every minute for that matter.
Yes, exactly. And that's a great point. And also a best practice to have short-lived certificates as opposed to long-lived ones in case there's a compromise in that particular regard. So you want to make sure that it's as short as possible so that in the case something goes wrong, that certificate would have expired. And for my private certificate authority, I'm using AWS PCA. which actually also has a short-lived mode for the certificates that it issues. So let me just quickly switch back to this diagram here so you can see this setup again that I walked through is essentially what we have on the left side here. And so now we're extending the process to try and essentially bridge communication with AWS Private Certificate Authority. And so there are a couple of different components involved in the process. You have to install Certificate Manager, which is going to act as a facilitator. But in addition to that, Certificate Manager also has an extension or an add-on known as the Istio certificate, the Istio CSR, Certificate Signing Request Agent. This is a Cert Manager agent that essentially works with Cert Manager and will allow you to plug in to an external root certificate authority. And so I'm going to be using Istio CSR with the AWS PCA issuer plugin. And the AWS PCA issuer plugin is another component that allows you to essentially communicate with AWS Private Certificate Authority for the signing of certificates and the issuing of them. So that's just so we have a high-level overview of the main components involved, but I've numbered them to make it easier just so we understand how are things actually flowing. Otherwise, this can be so overwhelming to understand. But in this process, what actually happens is the hierarchy shifts. Now that we've got a root certificate authority outside of our environment, inside of our environment, we're going to have an intermediary component. So Cert Manager becomes the intermediary certificate authority. So the process starts off just like the default flow, where the Istio agent sends their certificate signing request to Istio-D. Now, in this case, because Istio-D is no longer the root certificate authority, it will communicate with Cert Manager. And Cert Manager, in this case, is now using the Istio CSR agent. The Istio CSR agent will then communicate with the AWS PCA issuer plugin, which in turn communicates with AWS Private Certificate Authority. And when that certificate is signed, and it is then issued back through the same components from the AWS PCA issuer to Cert Manager, and Cert Manager back to the Istio agent. And so that is then a signed certificate request that is now owned by that particular component. And it is still a SPIFFE verifiable identity document, but now it has been signed by the root CA. I'm going to pause there in case you have any questions or comments.
I have two comments. First of all, thank God for Cert Manager. I mean, Cert Manager is the workhorse here, right? So it's the exactly unsung hero of all our infrastructures. If he wasn't there, somebody should have invented it already, right? So, but also I think it's just an idea, right? What if one of those cloud providers will come up with private CAs or certificate managers that can issue directly SPIFFE identities? Maybe that's an idea for so you don't need to go through a bunch of redirection and get SPIFFE identity directly from the cloud. But that's an idea. It's a feature request. Maybe I should make some noise about it.
Right. Yeah. No, excellent. Absolutely. You want to definitely minimize the number of components, intermediary components in the process as well.
Yeah. It happens.
Great.
So this is also what we see in OpenTelemetry, right? So it's the cloud provider that adopts the open source standard. And this could probably maybe will happen also for SPIFFE identity. They will become the de facto standard for providing identity and then verifying identity. There will be just adoption from everywhere. So.
Exactly, and it's platform agnostic, which is great. So it enables interoperability, which is one of the key aspects or traits of SPIFFE.
Yep.
Great. So what I actually want to do now is show you some of the source code related to the implementation of these things. So I'm going to go back to the top. So that was the internal environment. And so to enable this process over here, the main things that we're concerned with are the ingress, which is actually managing this load balancer, and then the gateway resource that you implement for your particular your service mesh and the particular workloads or upstream services that you want the gateway to route traffic to. So let's start off with the ingress. And I'm going to increase the size of that. Is it clear?
Oh yeah, it's. I mean, okay, I have a big screen, but I can read very clearly. Yes.
All right. Fantastic. Yeah. I'm not going to go through this line by line just for the sake of time. I want to be able to cover other things, but and all of this source code will be made available in a public Git repository for people to recreate in their own environments and to test it out. So, you know, we see the common top level fields that you would have with a Kubernetes manifest file. I'm scrolling too fast here. You know, these are the usual suspects that you expect to see: API version, kind, metadata, etc. And the annotations are essentially what drive the behavior of the load balancer. So I'm actually using the AWS load balancer controller for this. And so I specify the class that I want it to be an application load balancer. It's internet facing. And then some really important components related to what we're specifically dealing with is over here, the backend protocol is HTTPS. So if we wanted to terminate TLS at the application load balancer and then simply have unencrypted traffic between the application load balancer and the gateway, then this would be HTTP. But in our case, because we're proxying it through to HTTPS, another HTTPS path, that is why we've set that up in that particular way. And of course, you specify the listening ports, port 80 and 443. If I scroll down here, under the spec section, this is where you define your routing rules. And like I mentioned earlier, your ingress essentially enables or empowers you to route traffic to multiple different environments. You may not have all your workloads running in an Istio service mesh. You know, you might have them, you know, some that don't need a service mesh, but they're running in a Kubernetes environment. And so this is a way for you to essentially route traffic based on a particular host or based on the particular rules. So in my case, my domain is lukonde.mwila.com. And so you can see that, by the way, I think I have it specified over here that I'm force redirecting all traffic to be HTTPS traffic. If I scroll down further, you'll see that the backends are the Istio ingress gateway, the health check, that particular path over there to ensure that that upstream path is healthy. And then, of course, the backend upstream service for the Istio ingress gateway itself. And you can see the port number is 443. So the application load balancer is going to proxy traffic through to the Istio ingress gateway. And then next is the gateway component. And I've named my gateway e-commerce gateway because I have a mock e-commerce workload. They're just two microservices, orders and products. It's the one that I use in a lot of videos. The namespace is e-commerce. And you can see that the particular selector over here is ingress gateway. And you can have multiple gateways for your in a single service mesh environment. Sometimes that's actually a great way if you want to increase performance. You can have multiple gateways as opposed to having a one that routes all the traffic to all these different services that may not even be related. But you'll see over here that I'm exposing traffic strictly on this particular port, which is 443. So I'm only accepting HTTPS traffic. And I'm going to refer back to the diagram just so there's some clarity around this. You'll recall that I mentioned that I'm attaching a particular certificate to the gateway, and that certificate is stored in a Kubernetes secret. So you would reference that over here in TLS and set and you decide on the mode, whether you want it to be mutual or simple. But then the name of the actual secret is here in credential name, which is e-commerce TLS secret. So that secret is what houses the particular certificate details. And my certificate has been issued by AWS Private Certificate Authority. I just realized there was something important that I skipped over here, and that's this part. The certificate that the public certificate that we attach to the ingress controlled application load balancer, you would attach the ARN of that certificate, the Amazon resource name. It would go over here.
Would that enable?
I'm going to pause there. Yep.
Would that ARN is? I think it's crucial, right? Because based on that,
Yes.
You authorize I guess is the who makes the call here is self-managed, right? Yeah. So based on that.
Sorry. Yep. Go for it, Alessandro.
No, I mean, so based on this IRN, cert manager makes a call to the AWS API to retrieve the certificate. Am I wrong here?
So, so at this point, we're still actually just dealing with this component over here. So the ingress we've got an ingress, which is managing this application load balancer, and the ARN is what references the specific certificate that has been the public certificate that's been issued by AWS Private Certificate Authority. But in order to actually have permissions to access that, you can either use an IAM role for service accounts, which is the more secure approach, or you can attach a particular policy with the permissions to access this particular certificate. So this call would actually be either from the node, the role attached to the node in an EKS environment, or it can be an IAM role for service account, which has the relevant policy attached to it to communicate with AWS Private Certificate for this particular certificate that's being referenced over here.
Yeah, I think I get it even with my limited AWS skills. This is telling the load balancer, the IRB, go get your certificate right there. And
exactly.
This IRN is like a unique ID of resources in AWS, right? So it's
yes,
just telling the load balancer, if you need our certificate, that's where you're gonna find it. I get it.
Right.
Okay. It's just coming from the Azure world is a bit different. In general, like maybe we can work together on translating this into the gateway API, which it's the new thing, and I'm getting some more interest in translating all the old ingresses, all the old Istio gateway resources into this new gateway API resources. So maybe something for our next UT.
Yeah, no, that sounds great. The second last configuration file that I want to go through just briefly is a custom configuration for Istio itself. And so the main thing that I'm swapping out that's really important, I'm going to highlight that here, is the certificate authority. So as I mentioned, IstioD is no longer going to be the certificate authority. Instead, I'm disabling that, and I want Cert Manager, specifically with the Istio CSR agent, to act as the certificate authority for Istio. So in the bigger picture, it's the intermediary certificate authority, but within the mesh itself, it's going to be the certificate authority. So that's what I'm specifying and configuring here. And you'll notice that under the components, and I've commented it here, and you can find these examples online as well, IstioD is being disabled, hence it being set to false as the certificate authority server in this case. What I want to do now is I'm going to stop sharing the source code.
No, it was so great. but please share the repository.
Absolutely.
To understand more.
Yeah. What I want to share now is K9S. And there's going to be a little bit of switching taking place here, but I want to switch to K9S now.
I have to confess, I don't like K9S.
Right. I mean, I'm hurt. I love K9S.
I'm old school. I mean, it's too fancy for me. Just
right.
80 columns, green over black. That's what I do.
Sure thing. And so let me actually switch to what would probably be the default view once you enter K9S. So over here, this is a view of all of the pods. And we don't need to get lost in everything at this point. We don't need to be too concerned about the pods. We'll get to that. But what I do want to switch to is the certificate requests. And if you recall the flow that I was showing in those diagrams, so we can also see the actual certificate requests over here, and we can see our issuer is AWS Private Certificate Authority. That's our root CA. And we can see all these different certificate signing requests that have been made. And we can also see right under the approved column that they're all set to true because that means that they've successfully been signed. And
can you show me two of those? I mean, what's the time difference between the two? Because there must be a timestamp, right? So
yeah, so that will be a little bit tricky just to show because right at the bottom we probably have our earliest one, so we can see here with IstioD. But let's try and find
I
find a
suppose
common
these
one.
are like emitted every. So this is 1946. I think this is like a early issuing of certificate signing request, and then
Right.
yeah, they say signs it. But yeah, interesting to
Exactly.
see. And it's okay that you have all
Yes.
these requests. There's no garbage
Right.
collection. There's no cleaning up. Maybe there is. Probably in Cert Manager.
So that's actually a great point. So you can actually configure whether or not you want to keep track of these. So I purposely set that to true so that I can actually be able to show this, because I think it's very useful to be able to see it. But if you don't want to, you can disable that as well.
Yeah,
so Reddit,
and it's good
yeah,
because it shows the spiffy identity that is on
exactly.
behalf of requested.
Exactly, which is what I actually wanted to highlight over here. Now, this is actually the URI format for a particular spiffy identity. And you can see that over here. So in my case, this is for the default service account, which is being used by my orders and my products microservices. They're both using the same service account. Now, obviously, a best practice is that they should have their own service accounts, in which case you wouldn't be seeing defaults over here. If it was orders, it would probably be orders SA. For products, it would be products SA. But I'm going to scroll down even further. Let's see. There we go. Just so you can see the additional details, I want to scroll down a little closer to the bottom. By the way, these are all short-lived certificates, so you can see the details over here for the particular issuer. Now, these are associated with the AWS PCA issuer plugin, but we can see the actual request over here that's made. And I'm going to scroll right to the bottom just so we can see there. Here's this actual certificate is highlighted over there.
Yeah.
Get right to the bottom, and there we can see these details. The status is set to true and that the certificate was approved. Certificate request has been approved by certmanager.io. Cert was issued.
It's great. Yeah, I can see how.
Right, and you can see this for
I want this by default in all my infrastructure.
Right, and so you can do this and you'll see that this is the case for the different components, and it's automated. You'll also see even the egress gateway and the ingress gateway get their spiffy identities signed specifically by AWS Private Certificate Authority. The last thing that I want to demonstrate is mutual authentication between some workloads running in this environment, because obviously we've now got the root certificate authority set up and configured, but we need to actually put it to use, right? It's no use having that set up for establishing trust, but we're not actually implementing it or applying it. So at this point, everything is set to a permissive mode. I've got orders and products are actually running inside of the mesh. So if you look under the ready column, you'll see it 2 out of 2. And the reason for that is because inside the orders pod, you escape and enter that again. You'll see our Istio proxy orders container. Exactly. It's the same case with products as well, but I've got another. Yeah.
I have to really leave in 3 minutes, but so I don't want to put pressure. But definitely,
I'm wrapping up.
If we can wrap it up, but I see the point. I mean, this is a mutual authentication between in mesh authentication. Yeah, please go on.
No, absolutely. I'm wrapping up here. So then the express test is not inside of the mesh, but if I was to shell into this.
So if this is a pod outside the mesh and you want to talk to a meshed service?
Yes. So at the moment, the mesh has a policy that is set to permissive mode, meaning that the mutual authentication is not strict. So you can see that I'm able to successfully communicate with the product service, which is inside of the mesh. If I just run a cat command on products, you can see I'm able to get the list of products.
Yeah, but there is no layer 7 policy. There is no higher level.
Right.
Yeah.
And so I'm going to implement a strict one. I'm just going to run a cat command on this so that you can see this is the peer authentication policy, and I'm restricting it to the case of the e-commerce namespace. And let me quickly modify this and set it to strict. So you can see now I've set it to strict mode. So I'm going to apply this.
My screen is frozen. I mean, I see our image is moving, but the screen sharing is frozen for me. But now I see exit.
Okay, great. So I've now applied a mutual authentication policy. So I'm going to shell back into the express test container, and I'm going to try and communicate with orders or products again.
And of course, it will fail because it only allows services that are part of the mesh.
Exactly, yeah, because I've set that to strict mode now, so you can see connection reset by peer.
Yeah, that's the zero trust in action, so we call it.
Right.
All right, I really have to run. And
we're all done.
Sorry to cut you short because I'm sure that there was a lot more to show. That was actually thank you so much, Luke. And I'm very, very glad you were on the show, and I'm sure we will find another time in the future. And I hope to see you in person finally and have the drink together. All right.
Great.
Thanks, everybody.
Thanks a lot.
Thanks. I'll leave the studio, and I think when everybody leaves the studio, then the stream will end. Thank you. To the next time.